So Comsol develops and sells a product called Comsol Multiphysics, which is used to simulate different phenomena in research and engineering, for example, electromagnetics, fluid flow, heat transfer, and structural mechanics. And the software is really used to predict what happens to a product when it's exposed to real operating conditions, for example, or to better understand a chemical process and the likes. It's a way of virtually representing reality. So Comsol has designed their product from the ground up with multiphysics in mind from the get-go. Computers back in the days, 20, 30 years ago, weren't really strong enough for doing multiphysics simulations, but we realized early on that this is something that will be possible and now easily is possible to do in computers. So we designed Comsol from the get-go with multiphysics in mind. And the way the software is structured is that it's the same workflow no matter which type of simulation you're performing, whether it's structural mechanics, fluid flow, electromagnetics, acoustics, chemical engineering. The workflow is the same all the time. And this has enabled us to capitalize on solver technology. Especially this year, we are introducing a variety of GPU acceleration technologies. And when we add solver technology to the software, it's available for all of this physics at once. And you can choose to work with just one of these physics, or you can choose to combine them. And it's really experience-based. The way that we have structured the software is that we can tune and fine-tune through different user interfaces the types of solvers and solver technology that is being used to ensure robustness and stability in the software. How do engineers correlate simulation data with physical test data? All right, that's a good question. So the first thing that you see when you perform a simulation is a pretty plot, if you wish. It could be a field visualized with color, it could be a stress field or a velocity field for fluid flow, for example. And depending on what you're comparing with, you can then export that data to a file, for example, to a text file with numerical data that you can then compare with corresponding data from experiments, for example. This could be done within Comsol as well. You can import data and do comparisons in Comsol itself, numerically or visually. You can also export data to a software like Excel or some other third-party software where you would keep processing and comparing data. And comparison then with simulation data from the virtual world with experimental data from the physical world. So version 6.4 is one of the bigger releases we've had of later years. It has three main functionality news that we think will excite most users. The first one is that we have GPU support across all physics. Previous versions of Comsol have been able to support GPU acceleration for training neural networks for circuit models, for accelerating things like simulation apps to make them run faster. We have also been able to utilize GPU acceleration for acoustic simulations. But what's new this year is that we have GPU acceleration for all physics. And that's a big step forward. And this is made possible by technology that is provided to us by NVIDIA. So this is something that has been developed by them and can be utilized in a fantastical way, I think, in our software in this release. So that's a very big news. The next big news is that we have introduced explicit structural dynamics. And this makes, for example, structural contact much more robust. It's much easier to make mechanical contact simulation run faster and more robustly. It also makes it possible to perform impact type simulations, like if you're dropping a cell phone on a table, for example. From which height can you drop it and it still holds together? And that is true for cell phones, but it could also be any other consumer product device that you would like to drop test. That is the type of simulation that we couldn't really do in previous versions, but now with explicit dynamics we can for the first time. So we're very excited about that. The third thing that I would like to mention is granular flow. We have a new granular flow module that makes it possible to simulate millions of solid particles, which when they are combined in bulk flow will behave a little bit between solid particles and fluid flow. So we have a flow of solid particle, and that requires specific tools and certain engineering approximations to be done efficiently. Again, something that our user base has been asking for many years, and we're really excited to have this completely new technology in this version.